Hi, my name is Renee Hemrick, and I'm from Colorado Christian University. Today I'll be talking about explicit teaching and instructional strategies in math. Explicit instruction is a structured, systematic, and effective methodology for teaching academic skills. Now, there are two underlying principles that go along with this teaching. Number one, data-based decision-making. This is when the data collected is used to make curriculum decisions. Therefore, curriculum-based assessment links the curriculum with the appropriate level of instruction. Number two, instructional alignment. This means that all the teaching variables match for optimal learning. The components of the teaching cycle match as well. Now, here are some principles. The main principle of explicit teaching is direct instruction. Instruction should be clear in approach and delivery, organized lesson plans, logical sequence, and guided independent practice. Now, we can see this explicit teaching strategies in RTI. We all know the three tiers of support. Tier number one, the core classroom instruction. Now, evidence-supported curriculum is used in this first tier. Differentiation by class configurations, extra assistance is given, and peer grouping is a strategy in Tier 1. In Tier 2, the reduced instructional group size, the mastery of the requirement of content. Content must be mastered before moving on to another content matter. Progress monitoring is done more frequently. The students are in a separate setting, and there's a qualified intervention teacher teaching. Tier 3, which is the intense individual intervention, is the smallest tier. There you will see personalized instruction, student participation, and essential life skills training. Now let's talk about the 4 instructional domains. Number 1, the primary goal of math instruction is conceptual knowledge. That's understanding math concepts and generalizing learning to real life situations. Number 2, declarative knowledge. This is a secondary goal of math instruction. This is obtaining and retrieving factual math knowledge. Number 3, procedural knowledge. This is an essential goal of math instruction. In this phase, development and implementation of sequential steps in math equation is developed. Number 4, problem solving. This is the culmination goal of math instruction. In this phase, analyzing and applying information in complex problems is achieved. Now let's look further at conceptual knowledge strategies. First of all, concrete representational abstract instructional process. This means hands-on manipulatives are used. You also can use dramatization of math problems. Number 2, plan for real-world application. In this strategy, word problems about topics of interest are used. Also, you can use technology, simulation programs, problem-solving software. All these help the student to understand the math more effectively. Also, you can bring in guest lecturers. Now let's look at declarative knowledge strategies. Number 1, custom time delay. In this strategy, teacher presents the problem. Then the teacher reads the problem and answers in the allotted time. If the student is incorrect in their answer, the teacher will prompt them with the correct answer. Then the student will repeat the problem and answer correctly. A second strategy is the 3-step labeling procedure. In this, the teacher models and the student copies the teacher. Then the alternating test pattern. You alternate between new and review examples. And then there's the delayed test. That's where the teacher will ask the student the newly learned example later on in the lesson. Let's look at procedural knowledge strategies. Number 1, the DRAW method. Using the acronym DRAW, discover the sign. Then the student will read the problem, then answer or draw and check, and finally write the answer. Another strategy is the 3 M's of demonstration. Model thinking in action, maximize student engagement, and monitor the student's understanding. Problem-solving strategies is the 4th instructional domain. Number 1, FAST draw. Once again, this is an acronym. FAST stands for find what you're solving. Ask yourself, what are the parts of the problem? Set up the numbers. Tie down the sign. And then use the draw that you used in the last strategy, which is discover the sign, read the problem, answer or draw, and check. And then finally write the answer. And number 2 strategy in this would be schema-based instruction. In this, you identify the problem schema. You look at the diagram and you decide which schema is being used. Once that is determined, then you write the critical information in the schema. Then you select and execute the operation to solve the problem. Here is my page of references that I used. Paul Halmas said, "The only way to learn mathematics is to do mathematics." By using the explicit teaching and instructional strategies, math can be taught effectively and caught completely.